Another closely related calculation is that of one-tailed probabilities. This is the probability that a random result will give you something that's off more than a certain number of standard uncertainties, but only in one direction, say higher or lower. So let's give an example. The day before the 2016 US presidential elections, opinion polls were saying that Hillary Clinton will get 52% of the vote, with a standard uncertainty, which is usual for opinion polls, of about 3%. Now, most newspapers therefore concluded that Hillary was going to win the election. But given these numbers, what are the odds that she would actually lose? As we know indeed she did. The newspapers ignored the uncertainty, as they always do. So here is what we'd expect her fraction of the vote to be. So average of 52, so it's the equation here for the normal distribution, mu of 52, standard uncertainty of 3, so sigma here is 3%. So this is what the graph looks like. And what we're going to ask is, what is the probability that she would get less than 50% of the vote? Now, of course, I know that in US elections you can get more than 50% of the vote and still lose, and indeed that's what happened to her. But let's assume it was a simple vote, and if she got less than 50% she would lose. So what we're after is this area here. Now that is the integral from minus infinity to minus n sigma, whatever fraction of the standard deviation you are away of all this. It's also the same number as the fraction the other side of being higher. So if you went from plus n sigma to plus infinity, you're going to get the same area. And it's basically just half the two-tailed probability. So remember, the fraction within an area is the error function of n divided by root 2. The fraction outside that area is 1 minus that. The one-tailed is just half of that, because it's only one of the two tails of the normal distribution. So in this particular case, we're asking the probability the result was 2% below the mean. So the expectation was 52%. What's the odds of it being only 50% or less? So that's 2/3 of a standard uncertainty, because the uncertainty is 3, the difference is 2, so 2 divided by 3, which is 0.66 standard uncertainties below the expectation. So n equals 0.66666. Divide n by the square root of 2, which gives 0.466. Calculate the error function of that, which actually comes out to about a half. So the chance of Hillary losing is, using this equation, a half of 1 minus a half. 1 minus a half is a half. Half of a half is 0.25. So there's a roughly 25% chance that she would lose. So that's what the newspapers should have concluded. There's roughly a 1 in 4 chance of Hillary Clinton losing. But a headline along the lines of, 3/4 chance of Hillary winning, 1/4 chance of her losing. That sounds a lot like academics having a bet each way. But that was the reality. Here's a handy table I pulled off the website here. There are many, many tables like this on the internet and in textbooks and other places, or you can calculate your own. Here's a number of standard deviations, standard uncertainties. Here's the confidence interval, the fraction contained in that interval. Here's the one-sided, one-tailed probability, the two-tailed. So basically this is just 1 minus that, and this is half of that. So you can see these sort of numbers which we've already looked at. So for example, 2 standard uncertainties, which is the one I mostly remember, you're going to be within that 95% of the time, so which means you're going to be outside that 5% of the time and outside in just one direction about 2.5% of the time.